Anyway, so I'm here to talk to you about safe programming with types. This isn't going to be a really technical talk. Some of you may know this stuff already. Some of you may just be getting a reminder of it. So you want to write a function. You want to take the length of a circular segment. What's a circular segment? Well, you've got two lines. You sweep out a radius, and it's this distance here. So it's L. In case you've forgotten your maths, it's a simple formula. L is basically the radius times the angle. Sorry, can you hear me? No? I'll push that up a bit more. How's that? Yep, I can see a thumbs up at the back. Great. So that's the formula. It's quite simple. No big deal. You can code it up. Nice simple way to do it. You call it arc length. You pass it a double for the radius, a double for the angle, returns a double, and it's just radius times angle. No problem. Look, documentation. When you test it, something doesn't seem right. All of a sudden, you're getting much bigger numbers than you should be getting. I mean, 45 degrees is an eighth, and a full circumference is about 6.3. So why are you getting 45? And this has probably bitten a lot of people. When you're working on trigonometric functions, they take radians, not degrees. So you change it a bit. You change the documentation, you test it yourself, and it's all good. Notice the new.pi. It's really handy. Swift 3 has done some really good stuff. You get roughly the right sort of number, about 0.8, which is about a quarter of 0.6. Oh, 6. There you go. All good. Done. Ship it. A user just goes ahead, just passes in an angle, calls you up, and goes, what the hell? I don't read documentation. Why am I getting the wrong number? Okay, now, you may have heard the story about somebody filing a bug against a feature that's actually there, but they don't know about it. The novice intern will laugh at them. The junior programmer or the mid-level programmer will just sort of say, close the bug saying it's already there, you just don't know about it. But the experienced developer will file a usability bug against it because somebody hasn't found it. So you're an experienced developer. Somebody's made a mistake. You could laugh him off, or you could say, I'll do better. I will make it safer. I'll make it harder for him to make that mistake. So you change the name of the parameter from angles to radians. Make it clearer, but you can still pass in the wrong unit. Nothing to stop it. You can use a type alias. But a type alias is a lie. It's not an actual type. It's just a pseudonym for an existing type. It's still just radians. I mean, you call it radians, but it's still just a double. You can't enforce the convention. There's nothing to stop the user from just doing something wrong, even for something as simple as this. We just create degrees, double 45, pass it in, then call you up going, why isn't this working? Look at my face. Tell me I don't know what I'm talking about. I've seen this done. So, Swift, we all know it's a strongly typed language, not like Objective-C, but it's still strongly typed, and you know that you can use strong types to help fix these sorts of problems. So, instead of saying, here's a double for an angle, you say, I'm going to use something that represents an angle, not just a number, and that will help against it. It stops people putting in the wrong thing into your function. So rather than just passing in a double, you have to pass in something that represents an angle. That means that the surface area of things that can go wrong in your function are much reduced. You may have seen the WWDC video this year about the measurements in units, which are due. It's really handy, lots of stuff in it. But lets you write more robust code because it provides new structs and new types, actually they're not structs, they're object classes, new types that actually represent the idea of something. So we changed this a bit. Excuse the indentation, it's not how I write code, honestly. It's just that you can fit on a slide. So you change it, you say radius is a measurement that has a unit length, and an angle is a measurement that is a unit angle. And it returns a unit length. Straight away, you've got documentation that says, I know what types I'm taking. I know I'm taking a length, I'm taking an angle, and I'm returning a length. And then you do your calculation within inside it. But you're saying, I have something that represents an angle. I have something that represents a length, not just a number and a number. You're familiar with this sort of thing. You have dates, which are basically a double, but they represent a unit in time. And they've done some changes to that in Swift 3. And that way, it doesn't matter whether they pass in radians or degrees or gradians or whatever you want. You can pass in, you could even develop your own idea of an angle, create a subclass of it that's a unit length, a unit angle, and pass it in. And you can see that your function will handle it, because all it does is it converts whatever it's passed in, turns it into a radian, does the calculation on it. So the types are constricted by what you can give you can pass into it. The methods that you can operate on that type are constrained by the type. As you can see, I'm doing a conversion, so I always get the radians value. And that's great. I can pass in degrees, I can pass in gradients, I can also pass in meters. And you can see that I'm getting something back. I mean, that's just a log output. I'm actually getting the value plus a unit. I'm not just getting some numinous value of, say, apples or miles or kilometers. Again, these things happen. People make mistakes. People don't know about metric and imperial, and they get confused. This way, it's completely constrained to it. And the new measurements API is really useful. Invite me back sometime and I'll tell you about it some more. So the type system is your friend. You've heard this said a lot before, but this is one of the things that it's talking about. You have to jump through a few more heaps. I mean, hoops. You actually do create things on the heap and the stack again. That's a different talk. But no, you have to jump through a few more heaps. It takes a bit longer to actually write out measurement is a unit length, measurement of length of meters and all the rest of it. But when you're actually using it at the call site, you tend to find that you're passing this value around, or you're getting it back from a function. So you use it once and you just pass it around. You're just passing the value around, and it's all neatly wrapped up. And so it seems like it's in this example, it seems like it's a lot of work to do, but it really isn't, because in the program it's a lot less and it's a lot clearer about what it does. It just makes it a lot simpler to fix. You can fix the bugs as they come up. It's a lot easier. The other thing you get from it is that the methods are self-documenting. Sorry about the indentation. It's a bit... it's bothering me. Let's do this properly. Let's use type aliases. Okay. In this case, I can have a type alias for length and a type alias for angle, and I can write my method a lot simpler. A nice simple function. I don't know what I'm calling a method. It's a nice simple function, radius, length, angle, fits on one line. When I said type aliases are a lie, I didn't mean they were bad. I just meant they had to be used with care. I already have a well-formed type. I'm just making it a little bit easier to use. Again, look at the documentation. You've got a summary that's sort of enough to tell you what it does. What goes in, what comes out. The trouble I have with type aliases, it makes it a lot easier to write code like this, but you sort of lose out some of the context. You look at the generated documentation, and it says length and angle, and unless you're working with this API all the time, you have to go look up what a length is and what an angle is. I'm not a big fan of type aliases. I prefer actually using the type. If you've ever seen a code base, and believe me, I'm working on them, where somebody thinks it's a lot easier to write a closure type as, takes nothing, returns void, and it's, just give me a bracket returning a void. It's a lot clearer than trying to read a type alias. That's just me. So what else you get is you get safer interaction between values. Not only do you get self-documenting types that you can't put the wrong value in, but when you're passing these values around, like you have two angles and you want to add them together and then figure out what the total length is, you can't add the wrong things together. You can't add a radian to a degree value. They have to be the same type. You can't make the sort of mistake where somebody passes in a different value and it's wrong, especially if you're returning properly typed values. You can't do it. So if you're adding up 2 radians, it works. If you're adding a radian to a degree, it won't work. So that's something else that won't bite you. Testing is a lot easier. Look at the method. You only need to create a length and an angle. However you create them, it doesn't matter whether they're radians, whether it's kilometers. As long as you know what value you're going to get out is so many kilometers for these two numbers, it doesn't matter what you pass in. The function will handle it. That's a whole lot of testing you don't have to do. That's a whole lot of testing you don't have to do for saying, what if I pass in a nil value? This method does not take nil values. It just takes values. You can't pass optionals into it. So again, the type system, which generates this function, restricts what you can do with it, which means restricts what you have to test with it, which means it's a lot easier. That surface area of things that can go wrong is a lot smaller. But you don't always have to create a full type. Sometimes you can just create a wrapper type. Maybe I could, rather than have to use the measurement type, if you're working before iOS 10 or Mac OS, I forget what it is now, Sierra, let's call it Sierra. You can't do it. You could say, I'll create a struct called radian and a struct called degree, and I'll pass in, and I'll just have it wrap a double value so that when I'm creating it, you actually have to create a radian and you have to create a value, and then you write your method to actually take it properly. You write your function to say, I will take a radian and I will take a degree. Okay, somebody could still pass in the wrong values, but at least This is a lot more clearer. Somebody has to actually create a value of this type rather than misread the documentation and pass in a degree. There's one less thing you have to worry about. And again, what this will do is you won't be able to add radian to degree. So although it won't completely stop the mistakes you get with users messing up their types, at least it mitigates some of the problems. There's another way to do it, which is sort of nice if you can squeeze it in. This creates two different types. You can do something called a phantom type, which is a really handy technique. So you create an empty struct of degree and radian, and then you create a generic struct called angle, which takes a parameter that it doesn't even use. It doesn't care what it is, it's just there. But that makes it a type of that generic type, even though you don't use a struct for radian. You create it the same way. No, I don't have to create initializers because the system does it for you. And then you can just create radians, an angle, that's a radian, a value.pi, and you can specify your function to take just that value so it doesn't mess around. Again, somebody could still pass in the wrong value for the angle, but it stops you passing in the wrong value. It's a really handy thing. I don't have the slide here, I was reading it on the way in, but I learned this technique years ago from an Objective-CIO post where they did it on file handles. And although the system will return you file handles for reading and file handles for writing, which won't let you read or write to them, it's possible that you will do that and then try and write to it and then you just get a crash later on as you're using it. But if you use a phantom type for reading and writing on this, it won't happen because if you try and pass in a reading file handle to a method that takes a writing file handle, it'll crash at compile time, not at runtime, and that, to me, is a better thing to do. But there you go, phantom types. So, I mean, that's about it for why you should use strong types. I mean, in summary, really, use proper types. If you can, use a proper type. Don't just use a double, don't just use an int. You can apply that phantom type or the wrapper struct around a string if you want to specify what things are. I mean, if you want to create an email address and say it's a string of type email so you can only pass emails around. That's one way to do it. The other way to do it is properly use the contact kit if you're going to do anything with users and emails and people. But, use a proper type. Don't just deserialize your JSON into a dictionary and then pass a dictionary around. Use a proper model object. Use a proper model object, pass that around, and use functions and parameters to get values out of it. I won't make you look at my face again. I've seen this happen far too many times. Type alias is not a type generator. I came to Swift after learning Haskell, and in Haskell there is a way to create type aliases, but when I learned it, it was always said don't just use a type alias, just create a proper type, because you can create a proper type. The type alias just makes it easier to read, and it may fool you into thinking you have a proper type, but you don't. Just have a real type and use a type alias just to make your code a bit neater. And you lose some of the local context, but just use it with care. And if you just want to create a very quick restriction around some already existing types, just use wrappers of phantom types. They're really easy to use, really easy to create. In a file, document them up a bit, and you find that once you do it, other people in your team start using it as well, and everyone's happy. What I really want to say is the type system is your friend. When people first started using Swift, there were lots of bangings over it, there's lots of force casting, all the things that if you've been writing Swift for about a year now, and at least certainly if you've done one breaking transition from one to another, you realize that these are the things that cause you the most problem, and people fight against the type system and try and squeeze things in. The migrator doesn't handle it properly, and you've got to go through and do it all over again. And even for the Swift 2.3 to 3 migrator, it does a lot of banging, and you have to go through and get rid of it all. But it seems like it's a pain. It seems like it's obvious what it is. I need to pass it. It isn't really obvious what it is. These are the sorts of things that when you write code at 3 a.m., you end up fixing at 4 o'clock the next day. Why are you writing code at 3 a.m.? Don't ask me. Okay. But the whole point of this talk is that I just wanted to tell you that the type system makes for safer programming. I mean, it's not all it does. It does lots of other things, protocol-oriented programming, generics, extensions, and all that. Invite me back sometime and I'll talk to you about those. But just using proper types in your code will make it safer, easier to use, and much more friendly. Thank you very much.